Welcome. Today we're going to do 174, 175, 176, and 177. We're going to try to squish all four on one video. Let's do it. Now, I'm loving this question because if I've said it once, I've said it 100 times. You must add variances. And I love questions that force us to use this rule over and over again so that helps us remember the rule. Taking a look at this question, it states, traffic engineers study the traffic patterns of two busy intersections on opposite sides of town at rush hour. The first intersection, the average number of cars waiting to turn left was 17, with a standard deviation of 4. Okay, so that's our first intersection. Now there was another intersection, and the average amount of cars waiting to turn left was 25, with a standard deviation of 7. So this could be just purely by chance. It just so happens there were 24 at one intersection, 17 in another. That we know that there's a chance of variability on any given day. So is this enough, assuming the data is independent? We're not comparing whether or not they're different. They're asking us to actually add them up, which makes sense. You might need to go through 2 intersections to get to where you're going. So they've asked you to report, if they're independent, what would be the standard deviation of the sum? Interesting. So if they asked you to add the mean together, so the mu sum or the mu total would be mu1 plus mu2, but they didn't ask you for that. And we want to just add standard deviations, but we cannot. We must add variances. So the standard deviation of the sum, or that you'd also think of as maybe the total, would be the standard deviation of one plus the standard deviation of the other, but you cannot add standard deviations. You must add variances. Well, the word variance just means standard deviation squared. So I can add variances, so therefore I'm just going to turn these numbers into variances. So the standard deviation of 1 is 4, and the standard deviation of 2 is 7. And if I add these variances together, I will get the variance of the sum. So 4 squared plus 7 squared should equal the standard deviation of my sum squared, which is my variance technically. Now 16 plus 49 would give me 65. And so my variance of my sum is 65, which means if I take the square root of both sides, my standard deviation of my sum, which is what they asked, is d, the square root of 65. Now, moving along, next question says, a newspaper wants to know the public opinion of a town regarding a construction of a new library. It decided that 48 people would be surveyed using a simple random sample. Which of the following would produce a simple random sample? So you kind of need to know what a simple random sample is. And in its purest form, every single person had an equal chance of being chosen. Period. End of story. Every single person had an equal chance of being chosen. So we can't really stratify, we can't group, we can't cluster, because that does not allow us to have every single person having equal chance of being chosen. So skimming through here, a phone directory, everyone might not be in the phone. Here's them stratifying by region. There may be more people in the Northwest, so that's not going to give everybody an equal chance of being chosen. We never want to do the first 48. We don't want to survey every fourth. So it looks like E in a census, and the word census means every single person. So if you had the number of every single person, you numbered them, and you used a random number generator, that's definitely every person having an equal chance of being chosen. So that's our answer. 76. Doing it. Suppose the probability that a softball player gets a hit on any single bat is 0.3. Now we're going to assume that the probability of not getting a hit is, so we're either saying you get a hit or you don't get a hit. All right, now it says assuming that each of these is independent. So this is a lot like our free throw example in class. We're going to assume those are independent. What's the probability she will not get a hit until her fourth at bat? This, the minute I heard that word until, this is a bits problem. That's a geometric. Now let's just take a moment to review these ideas. Is it binary? You betcha. Two outcomes, either a hit or a not hit. Is it independent? Yep. They said it was independent here in the problem. Is it until? The T means until. Yep, I'm gonna just not get a hit and not get a hit and not get a hit until I get a hit, and then I'm gonna stop. So we go until we stop. S, is there a defined success and failure? You betcha. There's a success, failure, and the two add up to 1, the probability of 1. So now that we've reviewed these basic concepts, this is really just a math crunch number problem. Your first at bat, we said no hit, no hit, no hit until the fourth at bat. So the first at bat is going to be no hit. The second at bat, no hit. Third at bat, no hit. Fourth at bat, hit. So what do we have here? You merely can multiply, because these are independent events, we multiply the probabilities. So doing that, we have no hit. Probability of no hit was 0.7. No hit again, 0.7. No hit again, 0.7. Finally got a hit on the fourth at bat. There we go. Multiply these up. I get my answer. B as in boy. Cool. Now, last question. It feels a lot like the one I just did a few minutes ago. Which is false? And these are all talking about power and alpha and beta levels. Okay. So what do we need to know? Well, we've said time and time and time again, the power increases as N increases or alpha increases. Period, end of story. So let's take a look if any of these try not to say this. It says the power of the test increases as alpha improves. Okay, yeah, that's exactly what I just got done saying, so that's true. The power of the test does not depend on sample size. Well, no, that's the opposite. So I've actually found my answer here. It's definitely B. But let's keep going. The next one says beta is a measure of the probability of getting a type 2 error. That's actually the definition of that. So that's definitely true. D, it says the power of the test is the measurable ability to test to detect a difference between the estimated value and the true value, and that's exactly what the power of the test is. And last, it says as the alpha level increases, beta decreases. And that's 100% true, because this is the probability of getting a type 1 error. This is a probability of getting a type 2 error. So you can either walk through door number 1 or door number 2. If you walk through door number 1, or you increases your chance of walking through door number 1, you're decreasing your chance of walking through door number 2. So all of these are true, except this one I'm going to mark as false. Thank you for joining us.